Hello. Today we'll learn pointer in C programming. In our previous class, we learned about array, multi-dimensional array, single dimensional array, and how an array in function. So that we have covered in our previous lecture. Today we'll discuss about pointer and how we'll use pointer in our C programming. That we'll learn in this class. And also learn how to create dynamic memory allocation. That means how to create array. Earlier class we learned define we learn array uh, that is static with static value. That means their pocket has been created with static value. But in this class we learn how to create array in dynamic. So user will give some input, maybe runtime user will take decision how many pocket will be created. So that we also learn in this class. And multi-dimensional array also we learn an array function. Next we'll learn programming pointer and array, pointer function, memory allocation. This we'll learn. So before start, we should know what is pointer. Pointer, nothing but a memory address. So everybody know how we'll declare variable. So whenever we declare any variable like int a or b, c, whatever name we have declared, that same one pocket is allocated in memory. One integer variable is declared in memory. So if we want the address of the memory, that means where the variable is allocate the pocket, where the variable is created, so that memory address we want, then we can collect that address and store that address in pointer variable. So pointer is a memory address. So whenever we declare any variable, then pointer value one address is created. That address is called pointer. Let's say example one. Suppose if you int a is a variable, that means one memory location has been created. If we store value a equal to 5, this is the value is stored in that variable, a variable. But in which memory location this variable created? The pocket has been created. Where? So if we want that address, memory address, then we should declare a variable int pointer p. Now we can collect that address p equal ampersand a. Earlier everybody used the scanf method. That time also use the ampersand for in before the variable name. That time I told that this is the address of the variable. Here we are storing the address. This pointer ampersand is written the memory address of the variable a, and that value, address value, I am storing in variable p. We can store address value in p variable only when p is pointer variable. Here, one more important thing, when we declare any pointer variable, that time we are use asterisk sign before the variable name. Okay. So now I want to print the percentage %d address of variable a slash n value of a. And after that I'm putting comma A, comma B, P, comma A. Now I'm compiling this program and run this program. If you see that address of the variable is this and value of the variable is 5. This is the memory address. So this is runtime. It is our you can put here U for unsigned integer. I hope everybody know the formatting character D, percentage D, percentage U, everything. So if I run this program now, it is not same. I you can use. I think this is online compiler. For that, it's given the negative number. This is online compiler, so it's showing the negative number. I can run this program in our one local compiler. Maybe I can use this also. Just 1 minute. When I run this program, then you can see that value. Variable address. This is the memory address 6363567228. Right, and the value of the variable is A. Variable A is 5. Okay, so better when we use our online compiler, that time maybe we are getting some use address or negative value address, as this is our online compiler and that memory we are using, the server memory we are using, so that's why it's not returning the correct value. So better we run the program, C program. When we'll work in pointer program, that time we should use our local any compiler, any type of compiler you can use. I am using code blocks. So here int A and int P in the pointer variable. Int A is a normal variable, and we are assigning value A in we are assigning value assign 5 in variable A, and in P we have stored the address of the variable, and you are pinned that address and variable. Okay, I hope this is clear. And if we declare another variable, say I am declaring B, and I am creating another pointer value in pointer Q, and we are assigning the value Q equal to ampersand B, and I'm value set the P equals to 6. Now I'm printing the same things I'm doing here also. And B, I can put here slash in for next line. I can save this program. Before that, I should stop this program and run again. You can see that there is that this address, this is the A variable address, and this is the B variable address. Okay, so this address also we should know that what this address is only first byte. So when we declare any integer variable in C, it's get 2 bytes. Its capacity is 2 bytes, right? Or we can say that in 64 system we can say it is 4 bytes. Okay, so if it is get 2 bytes, that means in our memory have each pocket is 1 byte. So then when any integer variable declared, then it will get it occupy 2 pockets, 2 bytes. That means 2 bytes means one, and address of the variable, that this address of the variable is first pocket address. So if it is 2 bytes array, 2 bytes integer, then next byte should not be 25635672 24 and next address is 25 naturally, and that 25 will not allocate it any others variable because these two pockets are in a single variable for 2 bytes with 2 pockets is allocated. Two I'll not say 2 bytes is allocated there. Okay, this is our pointer variable b is allocated. So in A and B, both are pointer variable and we are declared there. Now I am assigning value. Suppose here A is 5 and B is 6 and we P and Q are both are pointer variable. We are assigning value, assigning address A to P and B to Q. Okay, and we both value I have printed here. Now next thing is I want to assign a value through pointer variable. Suppose P equals to, I'm putting 5, say 9. Percentage D, if I print the A, then A value, A variable earlier, A pocket's value was 5, but I have set pointer P equal to 9. This value stored, this 9 stored in A variable. Okay, this is very important things. So 9 is stored in variable A as we are using pointer P. Pointer P is referring the address variable A. So when whatever value I am putting here, that value will store in variable A. I can print here. You can see that if I print that, if I run that program, then you can say the value will be 9. 9 value is printed. You can see that 9. So earlier value is A equal to 5, but current value is 9. I hope this is clear. Next, if I get another pointer variable, suppose I want to get another pointer variable, pointer. I want, you know, the P is also a variable. So P have also an address, So if I want that address also, then I should declare variable in this way in pointer key. This is double pointer. So when A is integer variable, that time we declare pointer variable, only single pointer I have assigned, only single asterisk sign I have put it here. But when I want pointer P variable address, pointer P is also a variable that is also created in memory, and that address I want. Okay, then I declare the pointer variable, pointer key, double asterisk sign and key. Now I can store the address of k equal to ampersand p. Now I want to print the value k. If I print percentage d, percentage d and print the k, then I will get the address value of p. I'll get address value of p, where p variable is created in memory. So when you done that, this is the p variable address. Okay, but if I want to print percentage d and print the p, then what value will be pinned? Sorry, I missed the semicolon. This is the A variable address 6356724. This is the A variable address, and this is the P variable address. Okay, so this is A variable address and this is P variable address. Now another important thing is, so whenever I am putting the value 9 in pointer P, that time the 9 is stored in variable A. Similar type, when you print pointer P, instead of P I am using pointer P, then it will print the p pockets value p pointer contain the a variable address, so a pockets value will be pinned here, a pocket value will pinned here. You can see the 9 is pinned here. Clear? Similar type, when we pin the k pointer k, now run this program and you can get that both are the same value as when we pinned that k variable and put the pointer sign here in this asterisk sign, then it will pin the value of k point, value of p, value of p means, what is the value of p? Value of p means a variable address, a variable's address pointer of p. So both value will be pinned here, 6356724, 6356734. Okay, I hope this is the clear. This is very simple example, but okay. Next point. This is one variable I have created and I have declared the variable and I have cleared the pointer variable and stored the value and in pointer variable, and that pinned p and pinned k. Both I have pinned. And what is the meaning of pointer k? So here another point is, if I pin the double pointer, then it will pin the a value, a variable value. It will pay the a variable value. 9 will be pinned. Again, I'm running that. Both will be the same value will be pinned. 9. This is our pointer and address. What is the address of the memory? So whenever we declare any variable, that time we allocated some space in memory. In memory have address. Each address have 1 byte pocket. So each memory, if you think that table, this memory is the table, and this is created, entire table is divided 1 byte. Each pocket value is 1. When you declare integer variable, then it will take 2 bytes. So then it will occupy 2 address. But here pointer value return only first pocket address, not second pocket, only first pocket address. So if integer variable take 4 bytes, then that time also only first pocket address will be written in pointer variable. So when we store the ampersand a, then value will be stored in first pocket address will be stored in p variable. I hope this is clear to everybody. Now I am giving another example. Earlier we collect the value. Let I am deleting this value. P and Q also I am deleting, not needed. B also needed. Okay. Now P equals to ampersand A. I am given here. Now I am printing comma P. Instead of ampersand A, I can put here P and print the value %d, comma A. What happened if I run this program? 56 I have entered, and that value will store in A. Why? In A, P is contain the address of A variable. P contain the address of A variable, and here we are getting the value in P. That means address of A. In A, instead of ampersand A, we are putting P. Now I'm pressing enter. You can see that printing A value is 56. Okay. So this value is stored in P variable, and we are stored in A variable. Okay. This also another example you can say. Now another interesting example. So now next question is, why we'll use pointer? We can use address, a variable name, even other than C++, all are using the variable name, not pointer value. Only C++, we can only use the pointer variable. So why we will use pointer? We can, in earlier program, we have not any issue. We can use that pointer variable. We can do everything. We can declare function, we can pass value, return value, everything we can do. We can do any type of calculation without pointer. But why we use pointer? I'm giving one example. Then it will be clear. Instead of definition, I am giving one example. Suppose, very common example, I am writing one function, swap, int x, int y. Here I am writing one variable, extra variable. I swap both value. So z equal to x and y equal to x equal to y and x equal to what happened? Equal to z. What happened? First, I am putting the value x value stored in z variable, just swapping the value. If you have 2 glasses of water, if you swap that glass, both water, then you should need one third glass, and you put 1 glass water, like x value are stored in z variable, then I have stored y value in x, and then I have stored y z into y. This different type of process to swapping the value. You can use the multiplication process, you can do the addition process, but this is using third variable. This is very simple way. For that I am writing here. Now here also you have declared two variable, int a and int b, and you have two value. A is 5 and b is 6. You have put it. Now you are going to print that value, percentage d, and a equal to this. Similarly, b equal to this, percentage d, a comma b, and also put the /n. This is okay. I think it will work. 5 equal to 5 and b equal to 6. Now you want to swap these two value. A value will go to b variable and b value will go to a variable. You call this method swap a comma b. Again you print that value. Now you run this. After swap, both are same. You call this value. You know a value is go to the variable x and b is come to in y, and that value you have swapped, but here is it's unchanged. That means when you call this method, that time you are passing the value of this variable, not passing the address. You are saying you are passing the value. In function, we can pass two type of data. One is value, one is address. Address means address of variable. That is called reference. So we can show in different way. We can pass value or pass by reference. Two types of value we can pass in our function parameter. So here we are passing the value. So whenever calling this swap method, that time your a variable will not go here. A value, what are the value? 5. 5 value is copy to x. So just like a value copy to x, a value is copy to x, and b value copy to y, and that swap, xy swap. So a b is unchanged. Both value is unchanged. So we are getting always the same things, 5 6 5 6. So though both are swapped, but swapped in xy, not in a and b. But instead of value, if we pass the address, then we should modify the function also. That time we declare this is pointer, and this is also I am declare as a pointer. Both are pointer variable. So when we pointer variable we have declared, and we are passing the address instead of value. I am passing here x is contain the address of variable a, y is contain the address of variable b, not the value. And now I am putting, instead in z I am putting the value. Earlier program I explained that what is the meaning of pointer X, that will return the value of pointer variable. So value means a value. X contain the a address, and here I also putting the pointer X, pointer Y, and here also pointer Y. Okay, now I am running this program. Now you can see that value is changed, because here we are changing the address, we are referring the address instead of value, we are passing the address, we are passing the address variable a and variable b, and that address value stored in a address value stored in x and b address value stored in y, and a value whenever I storing value a value stored in z, that is pointer x, so z will contain the a value, and pointer x and pointer y, that means pointer x means a variable, pointer y means b variable. So from function I am referring that the exact actual variable value b value will copy to a variable, and similar type z, I have in z I have already copied the x variable value, x pointer variable means a variable, and that y z value I have copied to y variable. So that's why I'm getting the swap value. So here you can say that swap value. In this purpose, this is very important in address. Otherwise, address is not necessary. But when we getting any function and we want to use the same address, same variable in method, that time we can use pointer. I can say another example also, that is, suppose you are writing one method. You are writing one method. That time you can return only one value. Everybody know that. So whenever any method is calling, method will return only one value, either that is integer value or float value, double value, long value, string value, character value, whatever. But it cannot be written multiple value, otherwise it will return nothing, that means void. It will return void. Void means it will not return any value. So suppose in your calculation you need multiple value, you are sending one value, you are sending, suppose in any example, suppose I'm taking one example, you are calculating total and average, you need total if passing 3 or 4 values, and you want two values, average and total, or total average, both value you need, you can return one value, but third value, second value, how will you return? That time you can pass the reference of the variable. Okay, then you can get multiple value. So pass by reference use in we are frequently used in our C++ program. Otherwise we can solve any critical problem. So this is very important for pointer in the pass by value and pass by reference. Okay, I hope this is clear. Pointer variable, value pointer variable, I have explained already. Argument and function, I have also declared this slide also. Next, what I'll do, no, before that I explain on more things. That is, in beginning I told we can declare array dynamically. How many pockets will declare? I pocket will be created, that will define dynamically. So how will create that? Before that, we should know two functions. One is malloc, one is calloc. So for that, we need one extra header file. We need another header file, that is include. I think everybody know the what is header file. stdlib.h. This file is needed. I am declaring pointer p. So this pointer p is a pointer, is an integer type pointer variable. So we can store data there. So if we store any value, then where it will store. So I want to create one memory and store that address, memory address in p variable. How we'll do that? I can do in this way. In p, I can use int pointer. This is typecasting. Then malloc. What type of data? What type of data memory allocation I want to create? Integer type. So then I'll put size of int. If I know the int size is 2 byte, then I can directly pass the 2, or if it is 4, then I can pass 4. But here I'm passing size of int. So if the machine is 32-bit, then it will get 2 bytes of pocket, 2 bytes integer, then it will automatically define. If it is 64, then integer will be 4 bytes. Then size of method will take decision. So I am not taking any decision. Size of method will return the variable size. Now, storing the value 90. Percentage t, comma, and p. Pointer p. Obviously, I should pin that pointer p. Okay. Now I'm running this program. The 90 will be pinned. So here one memory allocation is created and p value is stored on that variable. We have not variable name. Here we have not any variable name. We have only address. That is also in p pointer variable. So in this way, we can also create the dynamic memory malloc. Whenever we declare the variable int a, that time also same things happened. Memory also create the same things. But in this case, we are not declaring any variable a. Instead of that, we are creating malloc method for creating the memory allocation. Malloc method is used for creating the memory address. So this is for your understanding. So we'll declare variable in this way, simple way: int a, int b, int c, whatever name you can define. This is not needed, but whenever we declare any array, that's a malloc function is most important. How it's important? Let's give another example. Earlier, when you create any variable, suppose 90 pointer p. Now printf enter number of pocket, number of enter size percentage t, comma, ampersand a. Collect. You have collect the size of variable. Now you want to create the array in pointer p, or you putting the name for meaningful name, your ARR, what you familiar, ARR. Now you are getting int pointer how many pockets a into how many size size of int. Here I will create, suppose if anybody enter 5, then 5 into integer size. If it is 2, then 10 memory byte memory will be allocated, and that first pocket address will store in ARR variable. So then it is returning one, it's creating one array dynamically. Array is created, will be created. Now if I put that value, I'll not put 5, I'll put A. Directly I put A size. Slash D, comma 5. That will run. Now I'm running this program. I have submit SCA. Sorry, here. Scan. So initially I don't know what is the size of the array. During compilation, I have not defined the array size. I am collecting the array size, and after that I am allocating the memory here. So earlier when we declare array with static value, so there was one disadvantage. So if you want 100, if you declare 100 pockets, so and if you need only 10 pockets, then 90 pocket will be wastage. And whenever you need more than 100 value, that means the 110 values you needed or 105 values at that time, the array will be not out of bound. Out of bound. I've declared the what is the boundary of array, bound of the array. So that will be out of bound value. So that time we can't take decision what. So during runtime we can't take decision which how many pockets is required. But in this case, we can take decision. If it is 110, then we can put 110. If we take 1000, we can put 1000. If we took only 3, we can put 3. So whatever I need during runtime, user can take decision how many pocket he need. Earlier, programmer will define that size. Here, user will take that decision how many pocket will he need. Okay, this is the advantage of dynamic memory allocation. Now you are entering 3 value. So only 45, 46, 47 is defined. Only 3 memory. So no memory is wastage, and if more memory is needed, then user will take decision in initial in during the program runtime of this program. Okay, I hope this is clear. Here, one more example, one more syntax. This is not example. This same example. I am giving another syntax. Instead of ampersand array, this I can put another concept also here. Percentage D I'll put here and put ARR plus I. And I put pointer. This will also work. Instead of array index, this value also. If I put 5 and sorry, I put packet. Shut 55 entered. I don't have not time to enter 55 value. I put only 5. This value will print here. So here is printing the garbage value. Okay. I can put here I and there put a pointer sign. Okay, I'm putting the remove the packet. I think this should needed. And here is malloc size electron. What happened? This should be pointer. That is needed. Okay, this syntax is not supporting, so you can use this only. You can this only use this only. Array size. This value is printed here. Okay. I hope this is clear to everybody. I hope this is clear. Now I will declare another method, that is calloc. Instead, same type, similar type. Another method we have for allocating the memory, we can use calloc. Instead of malloc, we can use calloc also. This is also a one variable. Next, we'll discuss our some method, that is malloc, calloc, and free and reallocated. These four methods we will discuss. First, we'll discuss malloc method, which is used for dynamic memory allocation, dynamic memory creation. So whenever we declare any variable like int a, that means in one integer variable is declared in memory. But in suppose I want to create that memory dynamically. That time, what I'll do, I will create one pointer variable. I'll declare first one pointer variable, say int pointer p, and after that I will create dynamic memory allocation. So p equal to int pointer, and then I will use malloc size int. Okay. Now you can collect one memory allocation is created and that address stored in P. In this case, we are not declaring a variable. That means we have allocated some page, but that page have not any name. Earlier, we declare a variable by name and we identify the variable by name, and we get data or we put data, everything we using by name. But now we are not declaring any variable. We are creating one pointer variable address, integer pointer variable, and within that we have created one dynamic memory allocation. Malloc method used for creating the dynamic memory allocation. So for malloc method, we always use stdlib.h, and size up method is return the size of the variable type. If you get the float, then it should put pass float. If you pass double, then it will get double. Now we can number semicolon. Only P. Here we will not use ampersand, as ampersand return the address of the variable. Ampersand variable name means return the address of the variable. But here we have only address, we have no name. So for that we are passing only P here. And after that, when we try to print, then I'll like this ampersand, sorry, pointer P. Then it will print. Then it will print. Run this program. If you check that whatever value we have given, that value is pinned. But here we have declared one, we have created, allocated one memory that have not any name. Only we have only address. That address stored in variable pointer variable P. Okay, this is the dynamic memory allocation using malloc method. But this is very normal question, that why we will create that variable using malloc method. In this case, this is really not necessary. We always declare variable, and that time memory allocation will be created. int a, int b, whatever variable we want, we can declare. Then it will automatically create it, and we have the name. We can use that name in our entire program within the scope. Obviously, variable, every variable has scope. Within scope, we can use that variable. But then what is the utility of this malloc method? Why will create, when we'll create our dynamic memory allocation, where it's necessary? In earlier class, in previous class, we discussed about array. There we have declare, when we declare any array, that time we pass the value, how many pockets will be created. That value will pass static value we have passed, where constant value will pass in there. So during compile time, you have declared the variables array size. So in case, in suppose you think you have declared 100 pockets array and you are using 10 pockets only. Suppose in a program you need only, suppose you would declare 100 pockets array for storing marks for one class, any class, and there have only 10 students, then 90 pocket will be wasted. But same at the same time, if there have more than 100 students, then 10 pocket will be extra, 10 pocket extra you need. So then you will not, 100 pocket will not sufficient in that case. So how many pocket you will declare? You don't know. So in that case, it will be really difficult to solve this type of problem. So that's why we creating the array using malloc or calloc method. Malloc or calloc both are same type of method, but both have some difference. I'll discuss that. But both method used for creating the memory, dynamically creating the memory during runtime. And during runtime, when pocket create, that time you can supply the size of pocket, how many pocket will be created in array. In this case, I have two variable, one pointer variable and one AB variable. Okay. Now I am asking to user, please enter the size %d, comma, ampersand a. So user will enter the value, what are the size of array. Then you will create the pocket dynamically. P equal to, you entered int star. This is typecasting, integer type pointer, malloc, a into size of int. If integer have 2 bytes, then if user entered 5 during runtime, user enter 5 and integer have 2 bytes, then it will get 10 bytes of array. 10 bytes pocket allocated. And integer have 2 bytes, so 5 pocket will be defined. So if integer have 4 bytes and here user enter 10, then 40 bytes will be allocated and that value is converted to integer pointer. So each pocket value will be, each pocket content by 4 byte, each pocket contain only 4 byte. So 10 pockets will be declared here. So user will dynamically declare the array. And similar type, you can collect that value for b equal to 0, b less than 5, b plus plus. %d, comma, ampersand p, we can put I here. Same as array we can use. Same as array we can use. P here, P is a array. We can consider P is a array and we can use this way. Here we'll put, instead of 5, we'll put always A and B plus plus. After that, okay. Now I'll run the program. What is missing? SCA init %d ampersand PI, not I. It should be B. Here is variable is B. Actually, iterate variable always I. For that, I'm entering I. Now it's okay. I'm putting 4. So 4 pocket allocated. Okay, and 4 value is printed. So whatever data is needed, whatever pocket you needed. So if you needed 1,000 pockets, you can enter 1,000, enter the size, you will enter 1,000. If you 1 lakh, 1 lakh, 10, whatever packet you needed, pockets you needed, that pocket value you have to declare. If you want 10 pockets, then you will enter 10. If you need 5 pockets, then you enter 5. So whatever value you needed, that much pocket will be allocated. So no extra memory will be allocated. At the same time, no pocket will be wasted. So during our program with as a developer, we should always think how many memory you are using. So in that case, we can optimize our program. We are optimize our memory. So how many pockets is required? That amount of pocket will be declared during runtime. So I hope everybody understand that why malloc function and malloc function used. So calloc is also the same purpose. Calloc function is also the same things. Calloc function we can use in similar way. In here we can put the calloc only instead of malloc. We can calloc, but calloc have two parameters here. This is the different. This is one difference. Malloc need total size, total number of bytes malloc needs. How many bytes we need to create? But here, how many pockets and what each pocket size? So here two parameters needed. Other than that, everything is same. Everything is same. You can use same type. No issue, problem. Everything. I think it's run very fast. What happened? I'm pressing enter extra. 3 value is printed here. Okay. So malloc calloc both are using for memory allocation. Dynamic memory allocation. You can create memory dynamically. Okay. But what is the other difference for malloc calloc? So this I am saying only theoretically. In practical, I don't think it will support in our code blocks or online compiler. If you use the Turbo C or Valency, you can check that in your machine. When you create memory using malloc method, that time all pockets initialize with garbage value. But in case of calloc, all pockets value will be assigned is 0 value. So if you commented this section, then this value will be all pocket value will be 0. How many pockets you entered? All pockets is 0. But in case of malloc, it will return garbage value. But I don't think that value will display here due to this is compiler. Compiler will not is always 0. Put 0. I thought no. Here is printing that all our garbage value is printed. Malloc function, when you declare the malloc, then all garbage values, so all pocket values are garbage. You can check that. All are garbage value. Right? So when you malloc, you create the object as a malloc, then all pockets value assigned with garbage value. But when you calloc method, then all pocket value assigned with 0 value. This is second difference. So two difference. First is it have malloc have only one parameter, calloc have two parameters. But purpose both have same. And one more difference is malloc return our garbage value, all packet assigned with garbage value. Garbage value means which have no meaning. And calloc always assign the 0. Okay, this is the difference, main difference. So if you put those 10, then it 10 garbage value will be pinned. But if you get the using calloc method, then it will return 10 0. 10 0 value will be printed. Only this much is different. Other than that, malloc calloc are same. And one things also there are difference you can take as a note that malloc method perform very fast than calloc method. Okay, that is one problem. But here I can show that. In practically I can show that what is the how many fast is the malloc method. Second things, another method is one more things I want to say is instead of using array like index square within square bracket passing the index, you can use in this way also, like p plus b. You can also collect that value. Suppose you entered 4 And what happened? P4, percentage D, P4. Here I have read it. Sorry, here will not pass the pointer value. Why pass the pointer? P is the return the address. I told that you. P is the address plus B. B is the variable. Like 0. First B value is 0. So first pocket. P plus 1 means here when you plus 1, it will be referred to next pocket. Next B value, when B value is 2, then it will look at third pocket. When B value is 3, then it will refer to 4 pockets, like this. So here when you run this program, then you enter the 3, then 3 pockets value is created. So instead of using index, you can use in this way also, because when you clear printing that value P plus B, that means first time it will be 0, 1, 2, 3, 4, like this. First pocket plus index, that means that pocket you are mentioning that pocket. Similar way, you also pin that value. You also pin that value in similar way. You can plus B, and here you should mention the pointer sign, because pointer value you should mention which pocket value you want to print. In beginning, I told that what is the meaning of pointer. This value is printed. If you see that, if you look that, this is the interesting thing. 44 plus 1, 45, 46, 47. That means first pocket value plus B. This is not right. We want all pocket values. So we should put here within bracket address here. Sorry, 2 brackets is needed. If you put 6, now we can see that all 6 pockets value is printed. So this 2 line is very important for array. Instead using of array index using within square bracket, we can use in this way also. Okay, this is second example. In this way you can use. Second method is free. Free is another method. Free is just opposite of malloc calloc. Free method used for deallocate the memory. So you know that when you declare variable, every variable has scope. So out of the scope, the variable memory is deallocated. Memory is removed from the memory. So what space is allocated during the declaration of variable, out of the scope variable will be removed from the memory. That is the system in our C++ program. But when you declare the memory using, when you created the memory malloc or calloc method, that time you can deallocate also that memory. How you will deallocate? Just put free P, then memory will be deallocated. Okay, now we can again, you can declare memory P equal to whatever value you need, you can declare that. You can put here. Suppose you, after I remove that variable, you can reallocate it again. Okay, now you run this program and enter 4. You have entered 4 value, but all pocket value is 0, as after that calloc method again derive. First remove that memory, again P is defined. Okay, so if you not remove that memory and directly create again this memory, then 2 allocation will be created. But first allocation will be stay in memory. That will create some occupied that page. That page will be not released. So maybe in that case, if it is huge amount, if in case of 4 or 5 for 20 bytes or 30 bytes, it will not affect in your machine. But if it is 1 lakhs byte or 2 lakhs byte, then 1 GB, 2 GB memory is occupied, then it will be reduce your system performance. So always we use the free when you reallocate the memory. Okay, so similar type, another method we have, that is reallocate. If here you are deleting the existing memory using free method, after that you are recreating that method, this is okay. Suppose you want to reallocate the size. So during initialize, when you start, that time your size is you defined as 5. Then 5 pockets is allocated, and that 5 pockets value you have collected. But after collect, you think the no, you need more another 2 packets. 2 pockets you needed. So you want to add another 2 pocket within the our existing array. Here array means p pointer variable within address you want to create. That then what you will do? You will not free that method. You will just use the realloc. Here you will pass the a and how many pockets you will to create. Suppose I pass 2. Another 2 pockets will be created here. Okay. Then here also I'll put a plus 2, and here I am putting that value another 2 pocket means what value will be that p if it is a value is 5, then it will be 5 equals to 56 and p6 equal to 754. I am putting hard-coded value, not collecting the value from user. But this is not right, 5 or 6. Who told you that user will enter only 5? User enter any value. So better we should put a plus 1, and here we put a plus 2. Okay. Not 1, a plus 0, and here we put a plus 1 as our array index start from 0. So it will be a plus 0 and a plus 1. 56, 55 will be value entered. And here 2 pockets as this is hard coded. Here also put hard coded value. So now I am running this program. Here I have entered only 3. What happened? No pockets is allocated. Just 1 minute. Sorry. 5, 6 equal to 0. Size of a value correct. And here I'm passing wrong parameter. That's why it's happened. It should pass p comma 2, not mentioning the size. As we have during declaration we pass the size. So in array all pockets values should be the same type. This is the array definition. So all pockets value will be same. So we should not pass. We do not need to pass our type of the pockets. So just we pass this value. Now we are entering the 2, 3, 4, 4, 26, 26 value printed. Now I'll increase here 2 plus 2. Plus 2 value is added here. So here reallocate method is added additional 2 packet, additional 2 pockets. So additional 2 memory allocation is created. So if you want to increase your array size, that time you use the reallocate method. You should pass the array name and size. How many pockets you want to increase. This is the number of pockets you want to increase. And after that, you can add, again, you can collect, I have put it here hard-coded value, but you can enter that value from user and you can print that value. Okay. This is the reallocate method, p method, malloc method, and calloc method. And in pointer, this is very important. Okay. So that's it from this lecture. And thank you.